All right. So let's see. So, perform the indicator operation. Okay, so we have the second power of that thing, so you know how to do that. So, let's do that. -9 minus square root. I'm just going to right away take care of that square root of -25 thing. What's the square root of -25? That's 5i, right? Everybody okay with that? It's going to be 5i, right? Because square root of -25. Remember, negative inside of a root, whoops, we just pop it out, just take out that negative, and it comes out as an I. So it's I root 25, which is 5i. Good on that? So anytime a negative's in a root, just pop it out, that's I, because you can't have square root of a negative number, and then 5i. All right. Here we go. Let's FOIL this thing. So 81, negative times negative, positive 45i, boom, boom, positive 45i, and then positive 25i squared. So just doing a normal FOIL there. So far, so good. Let's FOIL that out. Okay. And then 45i, 90i. And then what is 25i squared? What do we always do with I squared? That's -1. Yeah, exactly. So the I squared becomes -1. Yeah, regular I stays regular I. Nothing weird happens there. But I squared is -1. Yeah. So here, I'll write that right here. I squared is -1. That's right. So what that means is then we have 81 plus 90i minus 25. So 81 minus 25, they're just normal numbers now. They can subtract whatever, 55? Oh, yeah, it's 81. 56, thank you. 56 plus 90i. There it is. Answer C. Good on all that? All right. Number 2, use the m4a-practice theorem to find the indicated power of the complex number. Write the answer in rectangular form. Ouch, not easy. Number 2 is hard right away. And number 2 is one of the hardest problems. All right, so I'm going to probably go to a fresh screen. And
are you sure about that?
I think so. I'm not sure, but fairly sure. Let's see. Number 2. So minus root 3 plus I to the 6th power. Okay, how do we do it? Well, of course, you could write out 6 of those and do all that, but that would be terrible. So I'm going to convert. The plan is convert to polar, do the 6th power, which is easy in polar, and then convert back to what's called rectangular, you know, with the I and stuff. Oops. So that's the plan. So basically I'm going to convert the thing to polar, do the 6th power in polar, which is much easier, and then convert back to rectangular. So the whole thing is it's easy to do a 6th power if you're in the other form. It's a pain in this form. And so we change to the other form. It's real. We have that special rule when you have angles, you just multiply the angles by 6, and and then you just come on back to this back to rectangular. So, all right, so that's the game plan. So let's do that. So we take this thing and we go, okay, how do we convert to polar? I mean, polar means like where you get an angle, right? We want to get an angle and an R. We want an R theta kind of thing. So how do we do that? How do we take that and convert?
R equals the square root of a squared plus b squared.
Yeah, Pythagorean, R is square root of a squared plus b squared. Put all these formulas right on your 3x5 card. So square root of a squared plus b squared, so that's the square root of, you know, and a and b just means this number here, and b is the 1 that's in front of the I. Yeah, there we go. So yeah, so the a and the b are just the numbers, the two numbers there. So square root of negative root 3 squared plus b squared is 1 squared. And so that's the square root of, what is that? What's the square root of 3 squared?
3.
Just plain 3, huh? Plus 1, square root of 4, 2. So r is 2. And now theta, do you remember how we always find the angle when we've got the a and the b thing?
Inverse tangent.
Inverse tangent, just like we did for vectors, huh? So that's kind of nice, you know, it covers both these last two exams, is whenever you have a like two things and you want to go back to an angle for them, it's just inverse tangent. But remember, we've got to be a little careful. It's the positive version of b over a, and then that gives us a reference angle, and then we have to adjust it for the correct quadrant. Remember that whole process, exactly like what we did for polar. I mean, this is polar. For vectors. Vectors and polar, both the same thing. Why b over a? Well, because it's like a slope. Remember, tangent is like a slope. B is the I component, right? It's the up-down. Remember the complex axis? The I went up-down and the first one sideways. So it's like xy in a sense, right? So it's always b over a. Okay, so it's tangent inverse b over a, so that'd be 1 over, on a, we just make it positive, going to make it negative root 3, positive. So 1 over positive root 3. So, let me see. Yeah, right, so it's going to be 60 degrees, isn't that 60 degrees? So you can do it in calculator, just hit the buttons on your calculator. I'm guessing my calculator's
30 degrees. Yeah.
30 degrees? Oh, you're right. It is 30 degrees. I'm thinking backwards. Thank you. So 30 degrees. Just hit inverse tangent button there on your calculator. Again, notice I made it positive root 3. Does everybody see what I did there? That's how we always do the inverse tangent. You have to make them positive at first because you're getting a reference angle, and then adjust it for the correct quadrant. So it's 30 degrees reference, because I made that positive. It's not the actual number. I would probably think, if I should, well, can't we just stick the actual number in, Mr. Aaron, to make it a negative like it actually is, and just get the straight answer? No, that won't work. It won't really give you the right answer. It'll give you something kind of messed up. So best way is, easiest way, I'm really giving you the easiest way. Just make it positive, get the angle that's reference, and then put it in the correct quadrant. It won't work the other way. So, all right, when I say correct quadrant, which quadrant does it go in?
Second.
Yeah, that's second, huh? Yeah, because remember, again, this is like an X and a Y, isn't it? That's what it's like in the complex plane. Remember the complex plane that has the real axis and the I axis, imaginary axis? The imaginary goes up and down, remember, and the real axis is sideways. That's what we're doing whenever we graph on polar graphs and things, right? That's the thing. So it's back root 3 back root 3 back root 3 up 1. Back root 3 up 1. So we're like right there, aren't we? So we're in quadrant number 2. So that means our angle theta that we're talking about, 30 degrees, is 30 degrees in quadrant 2. That means this is 30 degrees. This opening here. Right, it's always to the x-axis, right? That's what a reference angles means with referring to the x-axis. So that's 30 degrees. Well, what does that mean is the actual angle theta starting from 0?
180 minus.
Going to be 180 minus. We all comfortable with that? So the real angle, the true theta, is 180 minus the 30. So it's 150, right? Because you got to go 180 and then back up the 30, don't you? Remember that? 180 and then back up 30. 180 minus 30, 150. So 150. So that's always how we do for both. So you really want to get comfortable with that process. We do that for both vectors in the last exam. So there'll be, probably 2 of those on the final. One for vectors, one for these. So inverse tangent B over A, make them both positive. And making them both positive puts you in the first quadrant because remember, all students take calculus, all the trig functions are positive in the first quadrant. That's what I'm doing when I make them both positive. I'm getting us an angle in the first quadrant, a reference angle, and then we can find it in the actual quadrant it's in. You need, okay, that's right. All right, I'll be right with you. Feel free to have a seat. I'll get that for you. Question, Rudy.
Does that angle that you did the inverse tan of positive y over x always have to be in radian mode?
I was actually in degree mode.
Yeah, no, I'm saying when you get the reference angle, you get 150.
Right.
You convert that to radian.
Oh, we don't have to. Do not have to. No, I'm just going to stay in degrees. Yeah, good. Unless the answers are there, But yeah, I'm just going to stay in degrees. Good question. It's going to stay in degrees. So we got my angle 150. Okay. So now, what does that mean? Now we got our R right over here 2. We've got our angle 150 degrees. So we got our R. We got our 2. Excuse me. And now we're trying to put together the polar thing. So let's do that. What's our actual polar angle? Well, the way you do it, remember what it always is. It's R cosine theta plus R sine theta I. So that's always, it's very much like vectors, huh? It's like the same thing. Remember how the vectors were always R cosine theta for the x coordinate? Because remember, cosine is x. See how this is all kind of the same thing? Cosine is x on the unit circle, and sine is y. Same kind of thing. The only difference is for the vector, we had an I here and a j there. We were talking I and j for vectors. For the polar things, it's regular and I for imaginary, real and imaginary. For vectors, it was I and j. And it's all the same thing, whatever. It's the x and it's the y, isn't it? Cosine is always x. Sine is always the y. That'll never stop being the case in all those settings. Okay, so then, and also, we factor out the r for convenience. Cos theta plus sine theta I like that. Just factor out that r. And now we're ready to put that stuff in. I mean, what is the r? Well, we found it up here. It's the 2. 2 cosine of 150 plus I sine 150. Let me back up a little bit. There we go. Everybody good so far? So I just put in the R in the front, which is 2, and we figured out the theta, which is 150. So 2 cosine 150 plus I sine 150. And then use your calculator or go to your, oh no, I'm sorry. Don't do anything yet. Hold on. I'm getting confused. Let's stop right there for a second. We don't want to figure out what that is. We'd go right back to that form, and that's what we did all this work to not do. Okay, so we got our thing. Now we're ready to do 6 power. So we've converted to polar. All that was step 1, but that was the major step. So the other two will be simple. So that's the hard work, converting to polar. We've got our polar angle. Now, we'll go to fresh screen. So we have 2 cos 150 plus I sine 150, right? Now, so in other words, that's the same as this. If I actually figured out the cos of 150, sine of 150, multiply the 2, I'd go right back to negative root 3 plus 1i. It's just another way to say that same thing. It's exactly the same value. It's just in a different language. It's like saying 1 and uno, saying the same number in a different language. Okay, so what? Well, you're supposed to take that number, that complex number, to the 6th power. So now I take this complex number to the 6th power. So do you know how to take that complex number to the 6th power? Yeah, you say, okay, 2 to the 6th. That's normal enough. And then what do you do with the angles? By multiply. That was de Moivre's surprising theorem, is that you could just take the angles and you just multiply by 6. That's weird, huh? It's weird that a power of 6 would like multiply angles by 6, but that was exactly what de Moivre proved. That's why he became famous, because that is kind of an amazing result. So that's it. 2 to the 6th power is, use calculator, 64. Okay. And this will be cosine of 900 degrees plus I sine 900, right? Like that. And now just use your calculator. What is, and just multiply these things back. What is the cosine of 900 degrees? You don't even need to convert it or do anything. Just hit the buttons. Oh, I think I'm in the wrong mode. Yeah, make sure you're in degree mode. I'm in radian mode and got a crazy answer. So get yourself in the right mode. Cosine 900. Yeah, -1 plus I sine of 900. 0. That's convenient. So I just hit the buttons on my calculator, but make sure you're in degree mode, because those are degrees, and you're getting 64 times -1. Answer is -64. After all that, Chanu.
Yeah, it says, you know how you took the reference angle and you found the real angle?
Right.
I just used the reference angle and I got the same exact answer.
Every now and then that'll work.
Yeah,
It won't always. Yeah.
So I was like, hold on.
Yeah, good checking on that, yeah. Is that good on that? Yeah, Rudy?
Which part do we convert back to rectangular? Because it was like the convert
Right,
where it was-
right here. When I hit the buttons, that was converting back.
Okay.
See, this is rectangle. Once you have the eye, once you have the two things with the eye, that's rectangle. Yeah, so right there, this converted. Yeah, it's so simple, huh? The other way is the hard way to convert. It's almost like you don't even know what happened. Yeah. Convert to rectangular is when you actually figure out what the angles are. And you hit the buttons on your calculator. Yeah, that converted it back. Is that good on that one? So the answer was it none of the above?
No, D.
Oh, yeah, I better be careful. It's D. Yeah, D. It's D on there.
So that I doesn't matter though?
Well, because it's 0. 0 times anything, it's just gonzo. Yeah, normally it would stay around, but it was 0.
So if it was y, it'd be -60, or it'd be, -64i.
Yeah, right.
Okay.
Yep. Okay, so that's number 2. Oops, what am I doing here? Am I getting totally confused? What is going on with the... Oh, yeah, I need... All right, so... Oh, yeah, so they want me to... Yeah, so you can't just multiply them as they are. You got to change them. So let's do that. So take this first one, 2 plus 2i, and you got to change to polar, like we just did. Right? Like, meaning you got to find the angle, thetas, tangent inverse of... Do that, find the r, right? Do that. So change both of those. This one's kind of a lot of work. You got to convert them both to the polar thing, the r theta, and then once you got them in that form, you multiply them, which is easy to do once you're in polar. And so I'll let you work on that for a second. I got to grab the conversions, okay? So you put the 2 over the 2. Remember, you do the, well, they're already positive, huh? So that's tangent inverse of 1. That's what, 45 degrees? 45, but again, that's reference. But that's going to be the same one because this one's in quadrant 1. Am I going too quick? Does that make sense? When you graph the actual angle on this one, it's right to up to, isn't it? Right to up to. So it's in quadrant 1, so we don't need to adjust anything. That is the angle. Does that make sense? So whenever you do the theta inverse tangent thing, the angle you get at first is the reference angle. But if it turns out to, but when you graph the real thing, right, which means right to up to, this is right to up to, when you graph the real thing, if it is in quadrant 1, then the reference angle is the angle. No adjustment needed. But if it's in quadrant 2, 3, or 4, you have to adjust it. All right, so 45 is the angle. And what's the r? Square root of a squared plus b squared. So that's the square root of 2 squared plus 2 squared, 4 plus 4, square root of 8, which is 2 root 2. Good there. Okay, so we got that angle, so we got that one. So this one will become then, when all is said and done, this one becomes 2 root 2, you just put that in the front, cosine of 45 plus I sine 45. That's now the new version of Z1. The first complex number. Yeah.
You ignore the I when you do the R. When we're looking for R, because you did.
Yeah, right. Ignore the I. That's right. That's right. Is that good on that? So that's Z1. Let's go find Z2 now. So Z2, same kind of thing. I'll do that down here. And again, you got to do the thetas, inverse tangent on that. So I'm going to put when you do the inverse tangent, remember again, it's the positive b over the positive a. So that would be, B is 1, A is root 3. So B is negative 1, but I'm going to make it positive 1 over positive root 3. That's 30 degrees again, isn't it? 30 degrees reference. But then we have to put it in the correct quadrant. Am I going too quick? So finding the second angle. Let me let you finish that. Is that good? So 30-degree reference. What quadrant is it actually in? Fourth. Everybody getting that? Because the A, it's all about the A and the B. So it's over root 3 down 1, isn't it? Oops, kind of getting scribbly there. So over root 3 down 1, like that. So the angle is right here, and it's 30 degrees right there. Can you all see that? See how I came up with that quadrant and everything? So really, really important. You can do this because there's a lot of these on the test and exam. The last exam had them with vectors, same kind of thing. So again, the theta is inverse tangent. You got to put the positive B over positive A. Hit the buttons, and that's with your calculator, and that's reference. And then you put it in the right quadrant by finding where it actually is. Over root 3 down 1. Again, it's like an X, Y. The A and the B are an X and a Y. So over and down. So we're in the fourth quadrant. So the 30 degree is there. So what does that mean is the actual angle? When I say actual angle, I mean, from 0 all the way to there. That's your actual theta, starting from the 0 degree, going all the way to where that line is. So what's that actual angle? How do we find what it really is? It's 30 degrees reference, but what is it actually called? Reference in the fourth quadrant, so it's 360 back up 30, huh? So it's 360 back up 30. It's going to be 330 degrees. Is that good? Everybody see how we're doing that? Because it's 360 all the way around, back up 30. Back up 30 degrees. So, all right, so it's 330 degrees is the actual angle. So that means, and what's the R? We got to get the R also. The R is the square root of A squared plus B squared. So root 3 squared plus negative 1 squared. Square root of 3 plus 1. Square root of 4, 2. So, okay, so now we've got the R, we've got the theta, we've got Z2. So what is Z2 then? If I get a little room here. Z2 is R in the front, 2, cosine 330 plus I, sine 330. We good with that? Just like that. So Z2 is 2 cos 330 plus I sine 330. So that's how we always convert from rectangular to polar, right? Find the theta, the R, then the R goes in the front, cosine of the angle plus I sine of the angle. R goes in the front, cosine of the angle plus I sine of the angle. Now that we have the Z1 and the Z2, we can do what this was all meant to do, the product. What does product mean? Multiply. They want me to multiply these two. So really the hard work was all the converting stuff. Now this will be really easy to actually multiply them. So okay, so Z1 multiplied by Z2. So Z1 again is the 2 root 2 cosine 45 plus I sine 45 multiplied by the other one, which is Z2 times cosine 330 plus I sine 330. Okay, we're timesing those, multiplying those two together in their polar forms. So what did the theorem say when you multiply two things in polar form? Just multiply the numbers in the front. So that'd be 2 root 2 times 2 would just be 4 root 2, right? The 2 times 2 makes 4, and the root 2 just stays there. And what do you do with the angles? What do you do with the 45 and the 330? You actually add the angles, which is weird, isn't it? Like you're multiplying these trig things and you add the angles? Right, that's again the surprising theorem, but very convenient, very easy. So just add those up. You just add these angles, it's going to be 375 plus I sine 375, like that. Okay, and notice that they put the angles, the answers, in radian, so now we've got to convert those to radian. So take 375 and convert it to radian. How do you convert to radian? It's been a long time, hasn't it? It was like first exam. You multiply by pi over 180. Remember that? To convert to radian.
Would it be easier to subtract 360 first?
No, see, they've left it in unreduced form. Like that. Well, no, actually, you know what? No, let me take that back. I think you're right, Wendy. Why don't we do that? Yeah, let's do what Wendy's saying. I like her idea. Yeah, let's just convert Let's reduce it back. Yeah, good idea. I'm mistaken. I was looking at 23 over pi over 12, and I'm wrong. What I just said is not true. Yeah, let's subtract 360. Good idea. So subtract 360. So this is just 15 degrees. This is just 15 degrees, isn't it? When you subtract 360, more than a full circle. Good idea Wendy has. Let's just do that. Let's make it back to 15 degrees. And then let's convert the 15. Yeah, that'll be way better. Take the 15 and then multiply again by pi over 180. You guys okay with... You know how I remember that? Because it's easy to get it upside down and stuff. I remember it's chemistry that taught me how to convert units. Basically, you put on the bottom whatever you want to get rid of, because you're cross-canceling units is really what you're doing. Once I got that idea straight in my chemistry class, it helped me in many other of my math and science classes to not have to struggle to remember which way to do the conversions. You know what I mean? Because that's degrees. That's 15 degrees over 1. So if you're wondering which way to put this thing, well, you know you want to get rid of cross-canceled degrees. You want out of degrees, huh? So that's how you convert. That works for any time you're converting any units. You cross-cancel them. That's really what you do. So yeah, so that'll take me out of degrees. Degrees will cancel and go away. And I'll be in whatever else. So what do you got? 15 pi over 180. No more degrees. Degrees have canceled. So I must be in radians. Reduce that. Use calculator. 15 goes into 180. I imagine it's 12, isn't it? 150 and 30. Yeah, it's pi. So pi over 12 on that. Chinu.
Yeah, so when I was trying to do that one, I couldn't figure out the answer. You had that minus 360. I think that's the step I was missing.
Yeah, because it's over 360. Yeah. So, right. So yeah, good. Thank you, Wendy. So pi over 12. So which one of these is it? Is it D? 4 root 2 pi over 12. Yep. There we go. That's the answer on that one, right? Was it D?
Yeah.
Good. Questions I can answer on that one? These convert ones are a ton of work. I think these are some of the worst ones. No other questions? That good? So the ones where you have to convert are lots of work. Convert the 8 to polar. You'll get quicker at it after you've done it a few times. All right. So when we multiply polars, we add the powers, don't we? So convert this thing to rectangular. To rectangular. So we have theta equals 2 pi over 3. What should we do to take this thing and convert it? Like, say they want all these x-y equations. Like, which one of these x-y equations is going to be the same as this theta thing? What should we do? Any ideas? Tangent. Yeah. Right. Yeah, so if I took the tangent of both sides, let's do that. Let's bring in a brand spanking new tangent that's not already there. Tangent of theta. So I'm doing the same thing to both sides, right? So that's legal. That's correct. Tangent of both sides. Tangent of theta. Now, what is the tangent of 2 pi over 3? You can use your calculator. I'm trying to remember what it is. 60, 120. So what's the tangent going to be? Root 3 over 2. It's going to be root 3, isn't it?
Negative root 3.
Negative root
The sine
Oh.
of 20 is negative 1/2.
Thank you. So negative root 3. Yeah, so you should probably use the unit circle because your calculator might not give you, it'll give you like a decimal, minus 1.7, something. Probably. Is that what the calculator says? Minus 1.7, da-da-da-da-da, I believe. Yeah. So I want that. And what is the tangent of theta? Yeah, it's y over x. You want to have that. Well, yeah, we know that, huh? That's how we do the inverse tangent thing. That's how we convert. Is that theta is inverse tangent of y over x. Inverse tangent of y over x, yeah. Yeah, you could have just, maybe, would that be easier, guys? Maybe I'm confusing you. I mean, what I'm saying here is true. But maybe it would be easier for you, because you're so comfortable with this, and we use this all the time. We've just used it twice already. Maybe you would just like to say, look, I know that theta is inverse tangent of y over x. Just do that first. Would that be easier for you? Either way, that's fine too. And then, excuse me, getting over a cold and all this talking isn't helpful. Now, just take regular tangent of both sides. Same thing. I'm just showing you a different way to basically do the same thing I just did. The regular tangent will cancel the inverse tangent, and so we'll get y over x. Again, here's tangent of 2 pi over 3. And again, your calculator will tell you that's minus root 3. So here's another way to do the same thing I did. Last step, multiply. Put this over 1, cross multiply. Y times 1 is minus root 3x. So y is minus root 3x. What is it? Is it none of the above? Was that the answer on the thing? E was none of the above? Okay.
No, the answer is B.
So B? Did we do the tangent 2 pi over 3 correctly?
Oh, no, I'm sorry. I was looking at the wrong number. I'm sorry.
Let me get the unit circle, make sure.
Yeah, that's fair.
Excuse me. Let's see, where's the unit circle? Yeah, so tangent 2 pi over 3. Tangent is minus root 3 over 2 over a half. It's root 3 over 2 over a half. So tangent 2 pi over 3 is sine over cosine. Flip that up. Cancel, yeah, minus root 3. We were right. So it is minus root 3, so this is the right answer. So it's none of the above, which is always disturbing. But there are a few. Questions on that okay? So theta is inverse tangent of y over x. Take the tangent of both sides, gets rid of the tangent. Over here, tangent 2 pi over 3 is negative root 3. Cross multiply, there it is. All right, better move on. Okay, so they're giving me polar, and they want me to change to rectangular. How do you change from polar to rectangular? So this is the r, and this is the theta. So x equals r cos theta. Y equals, r sine theta. To convert, so that's not too bad. Here's finally a somewhat easier question. R is negative 3 cosine 2 pi over 3. Y is r, which is negative 3 sine 2 pi over 3. Good there so far? So you want to have those on your 3x5 card. X is r cos theta, y is r sine theta. That's, by the way, you can see why y over x is tangent, huh? See why y over x is tangent? Because it's sine over cosine, and the r's cancel. So that's where we get all those formulas from. Okay, so now find the cosine 2 pi over 3 and the sine. Go to that unit circle, same thing we were just looking at there. So 2 pi over 3 is right here. Here's cosine, here's sine, 2 pi over 3. Sine's root 3 over 2, cosine's negative half. So cosine's negative half. Sine is root 3 over 2, like that. So this is 2 negatives, positive 3 halves. Y is negative 3 root 3 over 2. There's the xy. So 3 halves, negative 3 root 3 over 2 is a b. Is that good? X is our cos theta, y is our sine theta. You'll have your unit circle again. It's still useful. Even though you can use your calculator, that unit circle is still helpful because it gives you the exact instead of just decimals. You need those exact answers. So definitely have that unit circle on one side of your 3x5 card. Yet again, he's very helpful.
How did you get 3 over 2 when you did the negative 3 times?
It's over 1. So top times top, bottom times bottom.
I see.
Good. Yeah, any whole numbers over 1 goes to the top. Good question. Other questions? That okay? All right, number 6 is a graph of a polar. That's fresh in your mind. We just did that homework, didn't we? Okay, so which one of those is the right graph? Can you tell by, remember we had those different forms we wrote out. You might be able to just, if you have the forms written down, you might be able to tell. So which one has, it's like 3-petaled rose thing. Which one of those had that? It's one of these 3 theta ones, isn't it? So now, it's not this one. It's not A, is it? Because that has a number added in the front. That's not how we did. If you look at the forms of the rose ones, it was not like that. So
It would be like over 3, right? Instead of on the origin.
yeah, that would do. Yeah, that make the. Remember when you had a number in the front? That made the limis. What are they called? The limicence or whatever. I'm pronouncing them weird, and all of a sudden, yeah. It was the different ones. Remember, if you look back, that when there's a number added, it's not. It doesn't just simply move it like that because it's not x y. Yeah, but it made the limicence or whatever they're called. All of a sudden, they escape me. It's French. The that's the limicence or whatever they are. No, so it's not that. So it's either 3 cos or it's either B or D. Now, which one is it? How do you know if it's B or D? What do you think?
You mentioned
One of the petals sits on the x-axis.
It's sitting on the x-axis, yeah. So what do you think?
Cosine?
It's probably cosine because it's sitting on the x-axis. But I would double check it to be sure. I'd plug in some kind of point just to be sure. Now, how do you plug in a point to be sure? I do a little bit of our theta work, maybe just 1 point. I'm guessing it's probably B. Let's plug in one, let's plug in just, actually, I like to put theta first, don't I? I think that's easier. So I'm going to do theta first. So I'm going to put in 0 degrees. At 0 degrees, if it really is 3 cos 3 theta, that would be 3 cosine of 3 times 0 degrees, which would be 3 cosine of 0. 3 times 0 is 0. Cosine of 0, look back to the unit circle. Cosine of 0, here's cosine, sine. Cosine of 0 is 1. So it's 3 times 1, which is 3. So 0 degrees, out 3. Perfect. Yeah, that's right. Right, when the cannon is aimed at 0 degrees, is 0 degrees. When the cannon is aimed at 0 degrees, it shoots the cannonball out 3. That is this point right here, which indeed is a point on the graph, isn't it? That is a piece of the outer edge of the leaf, the petal, of the rose. So yeah, it's working. I just checked 1 point. It's got to be B. That's why its cosine sits on the x-axis. That was the answer, right? B. So there we go. Everybody see how we know that? So that's enough work right there. If you know that the 3 cosine 3 theta, sine 3 theta have the 3 petals, and it's not a limicent. There it is, limicent. It's not A. Okay, you know, if you know the different forms, look back to the lecture, the 5.4 lecture. Look back to the YouTube on that. I went through the different forms. I laid them all out. I said if there was a number in the front, A plus B sine theta, that did a certain thing, and you know, on you go. They're all back there. Okay, divide. So, all right. So this one we're not going to need to convert anything. We're just staying in I form. So, what do I do with 9 plus 7i over 9 minus 6i? Conjugate. Yeah, do you remember that? It's like what you did back in your algebra days. Whenever you have the I with a plus or minus on the bottom, you multiply by the opposite sign. So you take whatever's in the denominator, 9 minus 6i. You change the sign in the middle to become 9 plus 6i. Multiply top and bottom by that. And here we go. Boom, boom. 81 plus 54i plus 63i plus 42i squared over. On the bottom, FOIL it out. 81 plus 54i, boom, boom, minus 54i minus 36i squared. Let's keep going. 81. These two right here, 54 and 63 make 117i, I think.
Yes.
10, yep, I. And then what do you do with 42i squared?
Negative 42.
Yeah, it's just negative 42. Is that okay? Is everybody okay with that? Because remember, I squared becomes negative 1, doesn't it? Regular i's stay as regular I, but I squareds become negative 1. On the bottom, we have 81. These cancel. By the way, that's why we do the opposite sign. You see why we do the opposite sign? Because it always makes the i's cancel on the bottom. We want no i's on the bottom. And then minus 36i squared becomes plus 36, because again, I squared is negative 1. So then that's 81. Oh, nope, it's going to be 81 minus 42. What's that? 39? So 117i over 110, 117. Adding those in the bottom. And now, let's separate those. So that's going to become 39 over 117 plus 117 over 117i. And is that 3? 1/3? 1/3 plus I. There it is. Questions on that one? Multiply the top and bottom by the conjugate, by the opposite sign in the middle of the denominator. Good. No questions. I'll move on.
How did you get 1/3?
Just calculator. 117 divided by 39. This goes into that 3 times.
Oh, I see what you're saying.
Yeah, so just left a 1 on the top. Whenever the bottom's bigger, it ends up being a fraction like that, right? All right, so we'll move on. So we have 2 minus 4i times minus 4 minus 6i. So we're gonna FOIL that out. So just FOIL that out. Just remember, I squared becomes negative 1. So we get minus 8, minus 12i, boom, boom, plus 16i, plus 24i squared. Good so far. These two make plus 4i. And this is minus 24 because the I squared is negative 1. Yet again. And so then that is minus 8 minus 24 is minus 32 plus 4i. There it is, B. These are easier problems now. Now things are getting a little better. Number 9 is going to be way easy. It's going to be the easiest one we had so far. So this is just combined like terms. I just distribute the negative. Distribute. Gather like terms. 1 minus 7 minus 2 is a minus 8. 6i and 7i is 13i. Minus 8 plus 13i. Here it is, D. Good on that.
What's the first thing you did? You factored out the negative?
Just distribute it. Anytime you have a minus in the front of the parentheses, just distributes. Anything in front of parentheses, just distributes. On that, good. Shall we move on to number 10? So just distribute the minuses through the parentheses, changing all the signs, and then gather like terms. Bless you. Okay, so 6 plus I squared is 6 plus I, 6 plus I. And 2 plus I, or 2 minus I squared is 2 minus I, 2 minus I. So yeah, this is a little tricky. We got to FOIL out the first two, FOIL out the back two. And then you got to remember that minus in the middle is eventually going to distribute through everything that comes from the FOIL in the back. It's going to change all the signs eventually. You have to wait and do it at the end. You can't do it right now. You have to leave that minus and wait and FOIL and then change after. So here we go. So I'm going to do this right here. So this will be 36 plus 6i, boom, boom, plus 6i plus I squared. Minus. And then, boom, boom, 4 minus 2i minus 2i plus I squared. See how I brought in extra parentheses, leaving this minus sign right here, leaving it in the front? It's going to eventually change all the signs to the right of it. So gather up some like terms here. 36 plus 6i plus 6i is 12i plus I squared is minus 1, right? I squared is negative 1. Minus, and then what do we got? 4 minus 2i is minus 4i. Again, plus I squared is minus 1. So we get 36 minus 1 is 35 plus 12i minus, and then in here, 4 minus 1 is 3. We get to there. And so that's 35 plus 12i. And now the minus distributes. Minus 3 plus 4i. It changes all the signs to the right. Everybody get with that maneuver right there? That's the step that often people forget, or they never set it up to do that from the beginning. That okay? You see how that worked? Now we just combine like terms. 35 minus 3 is 32. 12i and 4i, 16i. 32 plus 16i. C. There we go. Questions?
The negative one, I had the negative one, or? Oh no, you factored out the negative one, right?
We're talking about
The negative one?
which negative? There's a couple negatives. I see a negative one here, I see a negative one there. Which negative one do you mean?
Oh no, never mind, I confused myself. I didn't realize it. That from the I squared, I didn't realize it was from the I squared.
Oh yeah, I squared became negative 1. Yeah. That's right. Yeah, both I squareds became negative 1. Yeah, good. Other questions on that one? Say good. All right.
For the next one.
Now this is probably the hardest. Okay, so complex fourth roots of negative 16. So in other words, what they want is they want us to do the fourth root of negative 16. That's what they're really asking us for. The fourth root of negative 16. Now you might think, well, it's imaginary. You can't do it. Well, right. It's not real. That's why they're saying the complex. Not the real, but the complex, which has real and imaginary put together. Yeah. So we got to do it. So to do it, we've got to do what? Convert. They're not saying it, we just have to know it. You have to convert this thing to polar form. You have to convert it to polar form. So for step 1, minus 16. In fact, let me write it as it should be written. Minus 16 plus 0i. That's the same as minus 16, right? But we got to acknowledge that it has 0 imaginary part. Convert to polar. Do the 4th root. And convert back to rectangular. It's going to be a big, long, difficult one. So convert to polar, do the 4th root, convert back to rectangular. All right, so here we go. Let's take minus 16 plus 0i. I put it in the a plus bi format, right? This is my a, this is my b. That could be confusing right there, like, hey, minus 16, but yeah, you got to write it minus 16 plus 0i. Got to write it as an a plus bi format. So, theta, inverse tangent, you know the drill, right? The positive b over the positive a. So that's inverse tangent of b, which is 0, over positive 16. What's 0 over 16? Well, 0. Inverse tangent of 0? It's in fact 0. 0 reference angle. Let's be a little careful. Yeah, this is tricky. Yeah, there's a lot of tricks in this. I try to give you you probably picked it up. I try to give you the worst case scenario on the practice exam, so you've seen as bad as it can get. So it won't be any worse. The exams are never worse problems than the practice exam. So 0 degree reference. So that doesn't mean our real angle's 0. We've got to find where the real angle is. So what quadrant is the real angle in? Well, this is x and y, right? Back 16 up 0. Right, back 16 up 0. It's right there. It's not in the first quadrant. So it's 0 degrees right there. But what is that actual angle starting from 0?
180.
180. That's 180, isn't it? So our actual angle is 180. It's a 0 reference over there. It's 0 off the x-axis over here. It's not at all off. It's 0 degrees off the x-axis here, so it's 180. Everybody see that? 0 degrees is the reference, but the actual angle is 180 because of where it lies. So remember, are you getting the hang of that tangent inverse thing? You've always got to do tangent inverse, get your angle, but that's a reference. Then you go to the correct quadrant. There it is. So the actual angle is 180. Okay, so what's the r? Let's get that. Square root of a squared plus b squared, as you know. So let's find those. What is a? A is minus 16. B is 0. So this is a, this is b. So r equals the square root of, what is that, 256? Yeah, square root of 256 plus 0, and that comes back out to be 16. R is 16. Rudy?
At the top you had like the square root of negative 16 to the 4th power. Why did you drop the root of negative 16? Why is it just the negative 16?
Oh, yeah. Yeah, I'm just doing the negative 16 right now. I'm converting to polar now. I'll do the 4th root as my second step.
Yeah, but I'm saying, do you always drop the square root with it?
So what I'm doing is I'm taking the negative 16. They're asking me to 4th root it.
Yeah.
And the way I'm going to do is I'm going to first convert just the negative 16 to polar.
Okay.
And then I'll do the 4th root of the polar form, and then I'll go back. Yes, I'm doing the 4th root. So yeah, I'm dropping because I'm doing it in the second step.
Okay.
Yeah, so first step, right now I'm just converting to a polar number. Does that make sense? I'm just changing. I'm not doing the 4th root yet. I'll do that on the second step. I'm just converting this to a polar number. So there's my r. There's my theta. I've got a polar number now. So the polar form, remember, is always r cos theta. Where am I writing that? So it's always r. Whoops. It's So my polar form is always r cos theta plus I sine theta, right? So it's r, now I know r, 16, times cos 180 plus I sine 180. Good? There's, if you multiply that out, it would go right back to be just negative 16. It's the polar form of the number negative 16 in rectangular. Okay, so let's keep going. This is number 11. I've got the polar form now. Is 16 cos 180 plus I sine 180. So now it's time for the fourth root. So I want to take the fourth root of 16 cos 180 plus I sine 180. So how do we do the fourth root of that thing?
You gotta do the ends.
The Demoivre's theorem, whatever.
Yeah, Demoivre's theorem. Yeah, so you got to do the fourth root of 16 first off. So you do the number in the front first off. The fourth root of the 16 is just 2. Are you okay with that? Do you want me to show more about that? Why is the fourth root of 16 2? You could use your calculator if you have the fourth root button. Or you could just break it down. It's 4 times 4, 2, 2, 2, 2. Right? It's 4 2's, and a 4 in the hook is a 4 for 1 deal. So 4 2's, out comes 1. Is that good? You can use your calculator. It's 16 to the power of 1/4. Do you know that's the same thing? Right? Fourth root means 1/4 power, which is 2. So you can do that in your calculator. Is everybody aware of those algebra rules? Maybe I should slow down there for a minute. Do you guys remember from algebra that a root is the same as a fractional power? A fourth root is the same as a 1/4 power. And so if you want to just hit the buttons on your calculator like this, 16 to the power 1/4, you'll get 2. Or I'm showing here by hand how you could do it. You could just break down the 16, and then the number in the hook is the deal at Target, so to speak. That's how I always tell my algebra students. It's a 4 for 1. You're shopping at Target, it's a 4 for 1 deal. 4 2's for the price of 1. That's what roots do. Whatever's in the hook, that's the deal. It's a 4 for 1 deal. So 4 2's inside. I broke down that 16, which is 2 4's, which is 2 2's, 2 2's, 4 2's. 4 2's inside the store at Target. You pay for 1 2 coming out of the store. 4 for 1 deal. So by hand or by calculator, the fourth root of 16, 16 to the 1/4, same thing, is 2. So we did that part. And now, what are we going to do for the angle?
Multiply times.
Well, when you do powers, you multiply. When you do roots, you divide. Roots are opposites of powers. Are you with me on that? You want to get that basic, because there's too many things to memorize blindly in math. You really want to kind of get them a little bit more, then they'll stick with you better. What do I mean get them? Well, what does a power do? Like if I take the number 8 and I do third power, that means multiply a bunch of times, doesn't it? If I do third root, that's the opposite, isn't it? Roots are opposites of powers. And that'd be the answer 2. So think of roots as the opposites of powers. They are the opposites of powers. Therefore, remember a minute ago, when we did the power, we multiplied the angles by 4, right? If I took this to the 4th power, I would multiply the angles by 4. Well, now I'm doing 4th root. Oh, yeah, which is the same as 1/4 power. How about thinking about it that way? So I'm really dividing these by 4, aren't I? Dividing by 4. But it's a little more tricky than that. Remember what you have to do. How do we have to write this? What do we got to do? So we're not just going to take the 180. Remember, what we're trying to do is we're trying to say there's some kind of angle theta. There's some kind of angle theta. Trying to think of it. How did I exactly describe this to you? What method did I give you? Did I go with the way Math Excel did it? I can't remember now myself. So we basically say theta is going to be the 180 plus, and you want to write 2 pi k or n or whatever you want to put out there. Remember that kind of deal? So we're going to have to divide this by 4 now. Remember, there's extra options there. So whenever you're doing a 1/4 power, you're going to have the extra options. So divide through now by 4, like that, because that's what a 4th root is a 1/4 power. So divide through by 4. So what do you get then?
90.
What is that, 90? 45? 45 plus, and this is going to be 2 goes into 4 2 times. Pi over 2k, but you let the k be various options leading up to 4. Remember that? You let k be 0. Well, here, I'm going to write it on the left side. You let k be 0, k be 1, k be 2, and k be 3. Because that way you've got 4 options for a 4th root. So if k is 0, then theta is just 45. If k is 1, theta is 45 plus pi over 2. If k is 2, theta is 45 plus pi over 2 times 2. And if k is 3, theta is 45 plus pi over 2 times 3. You good with that? Now we got to change those. There's a lot of work on this one. We're real close now. Which way did they, let me go back and see which way they left the answer. Oops, wrong problem. Oh, they want us to go all the way back to rectangle. Yeah, right. I was hoping to skip a step. No getting out of anything. All right, so we good so far? So this is 45 plus pi over 2. Oh, instead of pi over 2, why don't we use 360? I'm sorry, guys. I shouldn't be mixing radians with degrees. That's probably not the easiest way to go. Let's put this back. Instead of 2 pi k, I'm sorry, let's put in 360k. And then we got to divide it by 4. So that'll be 90k. Yeah, let's try that again. Y'all with me? I lost you now by that step. So whenever you do the one, let me back up again. Whenever you do the 4th root, which is a 1/4 power, you do the number in the front, and then you take the angle and you divide by 4. That's what de Moivre's theorem said, is that when you do a power, that you can multiply the angles by that number. It's surprising. And so if you do 4th root, that's really a 1/4 power, so multiply the angles by 1/4. But the problem is we have to consider extra rotations, right? Because theta is not just one. You think, well, no, theta is just 180. Well, theta is really 180 plus any full rotations beyond that. You with me on that? 180 plus a full rotation is still 180, isn't it? Does everybody see why we're doing this plus 360k thing? It's because there's other ways to say 180. You could say 180 plus 360. That's still going to be the same spot on the circle, isn't it? Or 180 plus 2 360s. You're still at 180. So this is other versions of 180. Why do we have to worry about that? Well, because we're going to be dividing by 4. And when you divide, things that used to be beyond a full rotation are now within a full rotation. Yeah, that's probably a better way than I've said it before. Are you getting that concept? Do you see when you do this? Because we had to do this back when we were solving trig equations. I don't know if you remember. So, how do you know when? Whenever you're shrinking something, dividing, right? We're dividing by 4. We're shrinking. You have to consider things that used to be out of bounds. Because when you shrink, now they're in bounds. That's the issue. So when you're dividing by 4, which we're about to do, we're doing, then you've got to say, well, I got to think then about other 180s beyond a full rotation. Because they're going to suddenly shrink down to be in bounds now and valid answers. That's why we do that. So we consider extra rotations, extra 360s, k times 360 divided by 4. We get this, and then you let k be 0, 1, 2, and 3 to get the 4 different answers. If you went beyond that, you'd just be repeating. This will be all the actual bounds. So here we go. So now we're going to go plus 90 times 0, 90 times 1, 90 times 2, 90 times 3. So I get 45, and this is 135, and this is 225, and this is 315. There's the 4 angles. So there we go. There's the 4 answers. We got to convert them back to rectangular now. We're close. It's a long, long problem. So we got our 4 angles now, and we know our R in the front is 2 for all of them. That was the 4th root of 16. 16 to the 1/4 power. 2. So here we go. So it's 2, 2, 2, 2, parentheses, cosine, parentheses, cosine, cosine, cosine. Of what angle? Well, the angles are 45, 135, 225, 315. 45, I already forgot. 135, 225, 315. Plus I sine. Is that good on that? Those are our 4 angles, our 4 complex numbers. Now, just use your calculator or use the unit circle. We're just gonna, well, let's don't multiply yet. Let's just find out what is, because let's go to the unit circle. Pop up the unit circle here. We're always using the unit circle. He is our best friend in trigonometry class, the unit circle. Where is he, though? He's lost. There he is. So 45 degrees, cosine root 2 over 2. Plus I, and that's also root 2 over 2. Next one, cosine 135. 135 right here. Cosine is negative root 3 over 2. Negative root 2 over 2. Sine is positive. Next one, 225. 225 is right here. Cosine is negative, and sine are both negative. So we're just getting positive and negative, the same answers. Both negative for that one. And finally, 315. Cosine's positive, sine's negative. So I'm just going to the unit circle, grabbing the answers. All right, you with me so far? I just went and grabbed all those angles off the unit circle. And now we're just one step away. Distribute, the 2's will cancel, won't they? So it's going to be root 2 plus I root 2. All the 2's are just going to cancel. The 2 on the outside is going to cancel all the denominator 2's. And we'll get negative root 2 plus I root 2. And we'll get negative root 2 minus I root 2. And we'll get root 2 minus I root 2. There's the 4 answers. It's basically all the versions of plus and minus root 2's in the front and on the I. Wendy?
So it says the answer is B, but that's incorrect.
Uh-oh.
The first one's correct, and then the second one, they did a negative root 2 plus I root 2.
Oh, I'll look close.
It actually, it's in the wrong order.
It's in
It
the
actually,
wrong order.
all the answers are there. It's just in a different order.
Oh, is it?
They switched the second one is supposed to be the last one.
So it's all the versions of plus minus. Everybody got that down?
Okay.
We good? I'll go back and look. Let's see. So both positive. First positive, second negative. First negative, second positive. Both negative. Yeah, it looks like all 4 versions are there. It is B. Is that good there? So let's go over that again. That's the worst problem. All right, what did we do? We converted the thing to polar in the beginning, right? Where'd the problem begin? Back here. Yeah, so the whole thing was we converted to polar. We took the negative 16 plus 0i, found it on the unit circle. The angle was 180 degrees. Did the R, came out 16. So then we had polar form. Our polar form was here. 16 times cos 180 plus I sine 180. Then we did the fourth root, which meant the 1/4 power. Got the number in the front is 2. Divided the angles by 4, but to do that we had to consider extra full rotations. So 360k. Divide through by 4, that's 45 plus 90k. Did the k 0, 1, 2, 3. Got the 4 angles. 45, 135, 225, 315. Put them all back in the polar form. Multiplied them out into rectangular form. Got our answers. Just as easy as that. All of those are the fourth. What did we just do? You know, it's funny. You can sometimes do a bunch of stuff in math and go, here's the answer. But what is it? Those are the fourth roots of negative 16. Meaning, if I took any of those, and I'm running out of time just to finish the test, but I just want to say this. If I took any of them, let's say grab the first one, whatever, any of them, and did fourth power of it, it would, guess what the answer would be? Negative 16. It'd go back to the original. Because this is a fourth root. Meaning, it to the fourth power goes back. Notice, if you wrote 4 of those out, and I don't have time to, and foiled it all out and did all this stuff, you'd get back to negative 16, which means this is a fourth root of negative 16. These are all the fourth roots of negative 16. Any of those to the fourth power will go back to become negative 16. Kind of interesting, isn't it? That they're all like that. All right, we got to move on. No more time for... I'm going to have trouble just finishing this thing. Let's keep going. All right. So divide. I'm just going to put a bar right here. Boom. There we go. I'm just dividing Z1 over Z2. How do you divide in polar form? Well, you divide the numbers in the front, 6 over 12, right? Dividing. And guess what you do with the angles? Subtract them, right? You getting the idea? That was de Moivre's theorem, is that when you multiply, you add the angles, and you divide, you subtract the angles, which is weird. That's surprising, and that allowed us to do the power and the root stuff, right? If multiplying things means add angles, then power is repeated multiplying, so just adding up angles. All right, so here I'm dividing, I'm subtracting angles. So it's 3 pi over 2 minus 5 pi over 6. And then the other side, the cosine, the sine's going to be the same thing. So I'm just going to just do this one. Good enough. I'm running out of time here. 3 pi over 2 minus 5 pi over 6. How do you subtract those? Common denominator. Multiply top and bottom by 3. Got 9 pi over 6 minus 5 pi over 6, which is 4 pi over 6, which is 2 pi over 3. And 6/12 in the front, you know that's a half. So we have a half in the front. Our angle is going to be 2 pi over 3. So just look for the one that has a half in the front. Well, it looks like they all have a half in the front. And the angle 2 pi over 3. Oh, but there's 2 of them. There's this one and that one. Well, which one is ours?
Positive?
Yeah, see, they had positive in both of them. Nope, yeah, but you subtract it. It doesn't matter. It's positive in the front, so it's A. Does that make sense? They're trying to fool you with that minus in the middle. Don't bite. The originals both had plus. So it's plus. Is that good? Just divide the numbers in the front, subtract the powers. Let's go on to number 13. Here we're product. Product means multiply. We're multiplying these. So when you multiply the numbers in the front, add the powers, don't you? So I'm going to take root 3 times root 6. Run out of room here. And I'm going to add the angles. 7 pi over 4 plus 9 pi over 4. You with me? I'm adding the 2 angles. I'm multiplying the 2 numbers in the front. Root 3 times root 6 and adding the 2 angles. So what are we going to get there? This is going to be root 18. And then to add these, this is going to be 16 pi over 4. Now, the root of 18 is 3 root 2. 16 pi over 4 is 4 pi, which is 0 degrees. Is that too quick? Did I lose you? Square root of 18 is 3 root 2. Y'all aware of that? Because 18 is 9 times 2, and the square root of 9 is 3. Right? Square root of 18. 3 times 6 is 18. The root 3, 6 is root 18. 18 is 9 times 2. Square root of 9 is 3. So 3 root 2. And then I added the 9 and 7 to get 16 pi over 4. 16 divided by 4 is 4. 4 pi, that's just 0 degrees. That's just 2 full rotations, isn't it? That's back to 0 degrees. So the answer is going to be the 3 root 2 and the 0 degrees. It's just A. Is that the answer on number 13, A?
No, because the sine, cosine, and opposite.
It's D.
It's off the.
Oh, it's D then.
Oh, they reversed. That's trickery. That's just mean. All right, I didn't notice that. They tricked me. Yeah, they put the sign in the front. That was devious. So just the cosine is supposed to be. So is it D? It's not on the screen right now. So D is the same as A, but cosine in the front. Okay, yeah, that
Why
was
is it 0 though? I thought it would be like 4 pi.
4. But where is 4 pi?
I see.
Right? Because 2 pi is all the way right. 2 pi is all the way around once, and then all the way around again is 4 pi. It's the same spot as 0. 4 pi is the same as 0. It's 2 full rotations around. Is that good? Moving on. Number. So here we go. So let's do it. So minus 6 plus 6 root 3I. So got it. Basically, it's just changed to polar. So you know that the deal. Theta is inverse tangent of the positive 6 root 3 over positive 6, right? B over A. The 6's cancel. Inverse tangent root 3. That's 60 degrees, isn't it? So that's 60 degrees. And and they want radians. Oh, that's 60 degrees reference. That's the reference angle. Now we got to find the correct quadrant. What quadrant are we in? Back 6, up 6 root 3. Back 6, up 6 root 3. Yeah, we're in the second quadrant. So our 60 degree angle is from the x-axis in the second quadrant. So the actual angle is 180, back up 60. So 180 minus 60 is 120 is the actual theta. 120 is the actual theta. So let's convert that to radians. The easiest way is probably look at the unit circle chart. 120, go back over here. Where's 120? 120, that's 2 pi over 3. See what I'm doing? I'm just using the unit circle chart. 120 is 2 pi over 3. So you guys have this on one side of your 3x5 card, right? This thing's golden right here. This will give you a lot of points. So 120 is 2 pi over 3. It's so useful. So 120, that's 2 pi over 3. So 2 pi over 3 is our angle. And what's our r? Square root of a squared plus b squared. A is minus 6. B is 6 root 3. 36 plus 36 times 3. Right? Square the 6. Square the 6 is 36. Root 3 squared is plane 3. So use your calculator. 72, 144, 12. So 12 and 2 pi over 3. 12, 2 pi over 3. It's C. There we go. All right, I'm going to keep moving in the interest of time. How many questions are there? Ooh, 22. All right, so number 15. Convert to rectangular. So we have r is 2 cos theta plus 6 sine theta. Trick on this one, you got to multiply through by another r. Why? Because if you multiply through by another r, this will become 2r cos theta and 6r sine theta. And the other side is r squared. So I multiplied left and right by r. Why is that important? Because r cos theta is x. Remember that formula? And r sine theta is y. X is r cos theta. Y is r sine theta. R squared is x squared plus y squared. So there we go, it's A. Number 16, convert rectangular to polar. Okay, going the other way. So we have 8, change the color here. So we have 8x minus 5y plus 1 equals 0. So x again is r cos theta. and y is r sine theta, plus 1 is 0. We could solve for r, move the 1 over, factor out the r here, 8 cos theta minus 5 sine theta, move the 1 over. Am I going too quick? So I jump the 1 over there, factor out the r here, and then divide by the 8 cos theta. Why am I doing all this? Because I looked over at the answers, and they had r alone. So I'm going to divide by, what am I doing? I'm getting confused. Dividing both sides by 8 cos theta minus 5 sine theta. Boom, there it is. Minus 1 over 8 cos theta minus... Oh, it's B, isn't it? A reverses the order.
It says C.
It says C?
I think the correct, yeah.
No, the correct is B.
Oh, it's B.
B.
It's
B it is.
Oh.
All right, I'm going to move on. Time is running. B it is. So y squared is 2x. Y squared? Well, y is our sine theta squared. X is our cos theta. Good to there so far? Square this side. R squared sine squared. This is 2r cos theta, right? Okay, now what you could do is just divide out r on both sides. Gonzo here. Here it cancels one of those, so we have r sine squared theta is 2 cos theta, like that. And then get r alone, because they got r alone over here. So I'm going to get r alone. What do you do to get r alone? Divide by sine squared theta. Boom. R equals 2. Now, it's kind of hard to tell, like, which of those answers is right. This one or this one. It's not a 4. It's probably A or B, right? How do you know which one? Well, they did a little trickery. Do you see if you take the cosine over the sine, and what if you separate them? Do you see that right there? Right, I just took the cosine on the top. Sine squared I just separated. Why? Well, because they did some trickery. Cosine over sine is cotangent. 1 over sine is cosecant. Cotan, cosecant. Wait, is that none of the above?
What are those X's mean?
Is this answer none of the above?
Yeah.
All right. It is none of the above. Yep. Oh, I don't know why they put X's. Those should be thetas anyway. Anyway, none of the above for sure. That's a weird one. None of the above. It should be 2 cotan cosecant.
Is there going to be trickery like that?
I don't, the X theta thing, no. If that's what you mean, I won't do the X theta switcheroo. But otherwise, yeah. Everything else is fair game. All right, 18. So number 18, we've got 2 and minus 2 root 3. We're going to change back to polar. So this is x, y. Find the polar coordinates, okay? You've done this a million times. Theta is the inverse tangent of y over x. So inverse tangent of minus 2 root 3 over 2. 2's cancel. Inverse tangent minus root 3. Oh, you do the positive though, don't you? You do the positive. Root 3 would be 60 degrees. Go to your unit circle. Inverse tangent of root 3 is 60 degrees, or hit the buttons on your calculator. 60 degrees, and then go to the axis. Say which quadrant's it in. Over 2, down 2 root 3. Over 2, down 2 root 3. It's in the 4th quadrant. So the 60 degrees is in the 4th quadrant. Am I losing you in my acceleration speed here? You okay? I'm just doing the normal tan inverse, y over x. So what's the actual angle theta? 360 minus 60, right? So it's 300. So it's 300. So this is the reference. The actual angle is 300. Convert that. Go to your unit circle. Say, where's 300? It's 5 pi over 3. Right? Easy way to convert. Just go to your unit circle diagram. 300 is 5 pi over 3. 300 is 5 pi over 3. So there's my angle, 5 pi over 3. What's my r? Square root of 2 squared plus minus 2 root 3 squared. Boy, half this test has been converting, hasn't it? So 4 plus, what is that? 4 times 3, 12. Root of 16, 4. The r is 4. And 5 pi over 3. D. On we go. So 19, find another representation. They want another way to find the same spot, is what they're saying. So I said, okay, r, this is r and theta. So if you turn the canon to pi over 3, so you could go to the, let's go to the unit circle here. I mean the polar graph. Whoops, it's not the right one. Let's go to the polar graph. There it is. Okay, so let's turn to, what was it? What was the angle? It was pi over 3 and shoot out 3. So pi over 3, which is right here, and shoot out 3. 1, 2, 3, right there. So there's the point, pi over 3 angle, shoot out 3. They're saying, what's another way to find that same point? Go ahead, I'll let you use your polar chart. You want to use that on the exam tomorrow or Wednesday? That'd be fine with me. So bring your polar chart, you know, this thing that I gave you, and I'll let you use it on the exam. And so we find that spot, pi over 3, 3. And now they're saying, which other ones are the same? I don't know. You could go through them one at a time. Try this one, try this one, try this one. And try that one. It's probably D, isn't it? 4 pi over 3. So, oh, it's not the one it's B? It's D, 4 pi over, let me try, I'm just going to try them out. 4 pi over 3. Oh, this thing's off the screen a little bit, isn't it?
Oh, yeah.
4 pi, it is. It's the one I say, because there's 4 pi over 3. Right, can y'all see it? Yeah, there's 4 pi over 3. It's pointing that way. So the opposite of that is this way, negative 3. Yeah, that's right. If you aim the cannon at 4 pi over 3, but you shoot back, you're aiming the cannon this way, but you shoot backwards 3, 1, 2, 3. That's the same spot, isn't it? See how D is the same spot?
They want it between 2 pi and 4 pi, so you just add 2 pi to it, and you get 10 pi over 3.
Oh, I didn't look. Yeah, thanks, Ben. Yeah, they said, yeah, D's the same spot, but it's not the right answer because they said, look, we want theta between 2 pi and 4 pi. Oh, we're out of time, aren't we? Okay, we're going to stop there. That's as far as we got.